Welcome to the Nutley Cisco Academy. Today we are presenting routing.
The routing table of a router stores information about directly connected routes, which are routes added when an interface is configured with an IP address and is activated, and remote routes, which are routes that can either be statically configured or dynamically learned through dynamic routing protocols. Specifically, a routing table is a data file in RAM that is used to store route information about directly connected and remote networks. The routing table contains network or next hop associations, which tell a router that a certain destination can be reached by sending the packet to a certain router that is the next hop. On a Cisco router, the show IP route command can be used to display the IPv4 routing table of a router. Entries in the routing table can be added as local route interfaces, directly connected interfaces, static routes, and dynamic routing protocol. The sources of the routing table entries are identified by a code. Common codes include L, which identifies the address assigned to a router's interface, C, which identifies a directly connected network, S, which identifies a static route created to reach a specific network, D, which identifies a dynamically learned network from another router using EIGRP, and O, which identifies a dynamically learned network from another router using the OSPF routing protocol.
The best path is selected by a routing protocol based on the value or metric it uses to determine the distance to reach a network. A metric value is a value used to measure the distance to a given network. The best path to a network is the path with the lowest metric system. Dynamic routing protocols use their own rules and metrics to build and update routing tables. For example, routing information protocol is usually based on hop count. Open short path first is based off of cost on cumulative bandwidth from source to destination, and lastly, enhanced interior gateway routing protocol is based off of delay, load, and reliability.
Local route interfaces are added when an interface is configured and active. The difference between a local route and a directly connected interface are subtle. This is because local routes didn't exist until recently. This entry is only displayed in iOS 15 or newer for IPv4 routes, and all iOS releases for IPv6 routes. On the other hand, connected routes had existed for longer. The figure below displays the output of the show IP route command. Notice the 3 directly connected network entries and the 3 local host route interface entries. A local host route has an administrative distance of 0. This is similar to connected routes, but when redistribute connected is configured under any routing process, the connected routes are distributed while local routes are not. It allows the networks to not require a large number of host routes since the networks of the interfaces are advertised with their proper mask. The host routes are only needed on the router that owns the IP address in order to process packets destined to the IP address. It also has a /32 mask for IPv4 and a /128 mask for IPv6. The local host route is for routes on the router owning the IP address. It is used to allow the router to process packets destined to that IP.
Directly connected networks are added to the router's routing table if the interface connected to the network has an IP address configured. Connected routes always take precedence over static or dynamically discovered routes because they have the administrative distance value of 0, the lowest possible value.
Here are the questions you should all look up. And here are some of the answers. Thank you for watching. Please like and subscribe.